Hey everyone, welcome back to the channel. So a little bit of problem solving in design today. I have these stage lights. These are Chauvet Colorado 1 Quad Tours. These are an outdoor fixture. They have RGBW LEDs behind them, and we use them for some of our shows to color buildings and stages and things like that. Typically when they're used, they're hanging in this orientation, but we use them on the ground facing up to kind of color a building. And they're waterproof, but they have one, I think, small design flaw. We leave them outside for quite a long time, and they go through freeze-thaw cycles. And when they're in this orientation, a little bit of water, rainwater, will pool right here. And there's a little tiny exposed lip under there. And I think what's happening is rainwater is condensing and falling there and consolidating there, and when it freezes it expands and it pushes the glass a little bit away from the seal that's there, and we've got a tiny bit of condensation that gets into the light, only a tiny bit over the course of many weeks out in freeze-thaw cycles. But so what we want to do is we want to make a cover that goes over the light like this, that protects it so that rainwater doesn't consolidate on the front here. So we're going to go through the process of designing a thermoforming tool to make a clear cover that we can kind of tape onto the light over that. So the first thing we're going to do is take some measurements of this face and then draw a CAD model of this and then make a thermoforming tool for it. So we're going to take this light and put it on a piece of paper there and kind of draw Okay, so we're going to jump right in. We opened up Fusion 360 and we are going to start making that tool. So we're going to start by sketching on the top plane here, and we'll start with a circle. And we're going to make everything just a tiny bit bigger than we measured by about 1/16 of an inch so that it slips over easily. So the outside of this whole thing was 7.96, and then we're going to add 1/16 of an inch to that. And then there are these little cutouts in there. So we'll start probably with a circle out here. Create a line to give this an angle. Make that for construction, and then we'll set the angle between here and that line at 45 degrees. And then we know the distance from the center to that edge there is, well, the diameter is 7.47 from our measurement. So we're going to put a line, also a line here to the edge of the circle. And that's 7.47 divided by 2, because this is a radius. And then we will add 1/16 of an inch. Okay. And then we need to know the radius or diameter of that circle. So we'll measure the chord that intercepts the larger circle, which is 2.2 inches. So if we put a point where these two circles intercept, and then we dimension that at the length of the chord, which is 2.2 inches. That gives us that circle there. Actually, first we're going to do a circular pattern on that. So we'll create circular pattern. We want that circle and about the center point, and we want 4 of them. And then we can finish this sketch. And then the whole thing is 1 inch tall, so what we're going to do is create an extrusion on that center zone that's 1 inch tall. So that gives us the profile of our light there. And then we can sketch on this top surface here, and we have the center where the glass goes. So we can sketch a circle there, and we know the diameter of that is 6.24. So we'll set the diameter of that at 6.24. And we know that that was recessed 0.17 inch. So we'll do a cut here, 0.17 inch, and we will actually go negative 0.17 inch, and that gives us our recess. And then we have to cut this angle around the whole side of the thing. So what we'll do is we'll sketch on the front plane here, and we measured how far it went down. It came down from the top about 1/2 inch. So we will put a front plane sketch. We'll put a line here. We'll take this entity here and we'll project it into our sketch here. And then we'll bring a line down 1/2 inch. We'll make that perpendicular to that line. And then we'll put another line in here that also goes 1/2 inch. Here. And we'll dimension this. 0.5, and that gives us the area that we're going to cut. So now we'll take this and we'll do a cut. Actually, we need to do a revolve on that. So revolve that surface. We need a axis to revolve around, so we need to draw an axis line here. Finish, revolve. So it's got that profile. We click this guy, we do a cut, and that gets us our outer profile of the light. And then there's those 4 little bosses that we need to add. So we'll do another sketch on the top plane here, and we'll draw something that looks like them. So we can actually probably use a slot tool. Do a center to center slot. We want it to be in line with the center here, something like that. We want it to be lined up. We need a center line here, so center line, we'll make that a construction line, and we'll make the center of this and that line, we can make that and that coincident. And then we measured the width of that boss here, so it was a width of 0.4. So again, we're going to do 0.4 plus 1/16 of an inch. Okay, and then it comes out from the center here. So from this point, from the inside of the glass here, it comes out 0.75 inch. But you know, I'm going to move it almost all the way to the edge out here, because we really just care that it clears, that the tool goes around it so that it doesn't bind up on it. So I think that's good. We can dimension this so that it starts being fully aligned. So we'll dimension from here to the center point to fix that. Then we'll dimension the length of that slot, and now it's fully defined. And then we'll do another circular pattern here. So we want all of these objects, and we want them to rotate around the center point, and we want 4 of them. So there we go, we got that. We finished the sketch, and then we're going to extrude those profiles. But we're going to extrude them this way. That's a cut we want. We want them to be a join. And there we go. So that is the profile. We'll do some quick things, like maybe we'll add some little radii to those things. And the last kind of thing we need to do is on this first initial extrude, since we're making a tool, this is going to go into a vacuum form tool, so it needs to have a draft angle, otherwise it won't come out of the tool. So we're going to add a -1 degree draft angle, maybe even 1.5 degree draft angle. And that broke the cut, right? So we need to edit this sketch because now it's drafting out here. So what we can do is modify this sketch. We can project that edge onto here, so it'll follow it, and we'll draw a line between here and there, and then we'll make that point and that point coincident. Finish it, and then that cut will probably be missing a profile, so we'll add that profile back in. And now we have our tool. So you'll see later when we make this why we needed that draft angle, because it needs to be able to come out of the tool. So what it did was make the bottom surface here, the bottom of the part, just a tiny bit wider. We need them technically on these little bosses as well. So let's go in and do that. Let's add a -1. Actually, because of it'll be a 1 degree taper here. Okay, and I don't like how they came out over the edge there, so we'll edit that sketch a little bit, and we'll bring this in just a little bit closer. So 1.3, let's do 3.7 there. All right, and that's our tool that we're going to use to vacuum form this. So we'll hop right into manufacturing here. So we're going to use this stuff called Wren shape, and I have it already cut into 8.25 by 8.25 by 2-inch blocks, and I want the tool to be positioned at the bottom, offset from bottom Z and 0. Okay, so now the tool's sitting at the bottom and the whole part is within that. And then for my work coordinate, the easiest part for me to find is this corner on the machine we are using. So we're going to select that corner. That is correct. And we hit OK. So this kind of tool can be made pretty simply with basically one toolpath. So we're going to use a 3D steep and shallow toolpath, and we need to select a tool. What we're going to use is a ball end mill. We're going to use a 1/2 inch, 2 inch length of cut, 2 flute ball, and it's a wood tool, so it's a down cut tool. So we just described that here. It's 2 flutes. This one happens to be carbide. It's got a 1/2 inch diameter. Its overall length is actually more like 2.5. It sticks out about 2.25 inches below the holder, and its flute and shoulder length is 2.25 as well. 2.25. It's a long tool. And then we're cutting on a table router. I'm going to edit this foam, and this machine will do 18,000 RPMs. And cutting in foam, we can do something like 90 inches a minute. We could actually probably go a lot faster, but I don't want to go too fast because of the way we're going to hold it down. And no coolant. Hit accept here. Select that tool for our tool path, and let's see, tool containment can be I think it can be outside on boundary and bounding box. And before we do anything else, let's just see what that tool path gives us. And to be honest, that looks pretty good. We'll step in here and take a couple look at some more of the settings here. So we have this is giving us cusp heights of 6/10 and 3/10. So even this step over here, that's pretty small. You wouldn't even notice that in foam, really. So we could actually bring that up a little bit. We can rebuild that tool path. And then let's do a simulate. So no problem cutting at full depth in foam. So let's see, it's gonna speed that up a little bit and going all the way out. Alright, and we've got these little blocks left over, cutting right down to the bottom. I don't mind that. That's going to be just fine on the machine we're going to. So I think that's good. So let's post-process that. We'll call that program 1001. We are going to a Tecno CNC router, which is an HD series. Let's see if there's anything else in here. It all looks good. I'll put the program on my desktop, and I'll see you guys over at the machine. All right, so here is the piece of foam that we're going to cut the tool out of. And the way we're going to do this is use what's called the super glue method to hold it down. And the way we do that is we kind of clean our surface pretty well here. And we cover that surface in blue painter's tape. So we've done a similar tool for a different light on here before. So we're going to cover this with blue painter's tape. And the reason we chose this method is because we need to access completely around the part. You know, we need the tool to go completely around the part. So we then we do the same thing on the workpiece. And we take something hard and we burnish the tape so that it gets a very good adhesion to the surface. We do the same thing on the spoil board down here. And then we take some crazy glue and okay, and we let this sit for about 30 seconds with a little bit of pressure on it. And we set up our tools. There is our thermoforming tool, and we'll go head over to the thermoformer and make some copies. All right, so we have the thermoform tool here. Now this has kind of like a rough surface finish, so when the clear plastic forms over it, it'll be a bit rough. So for the lens in the middle, we have a flat piece of metal, and that'll make the center come out nice and clear. And so we bring our thermoform table up, put the tool down in the middle. Then we drop that down and we put a piece of thermoforming plastic in there. This plastic we're using is PETG. So then we get the vacuum formed part out, and then this should pop out. It'll take a little bit of force, and then the tool will come out. Could have used a tiny bit more draft angle probably. There's our tool, and there's our cover for our light. So a nice clear front. We got the frosting from the foam along the edge, and then we'll cut this out, and then we will go fit that onto the light. All right, so we're back. We've got the thing thermoform. We're gonna cut it out of our plastic here. First, we'll just kind of do a coarse job. And we'll come in and cut nicely along the vertical kind of wall there. Okay. So now we have our rain cover, and let's see how that thing. Let's see how it fits. There we go. Right on top. All right, looks like it fits pretty nicely. And then we'll be able to put some tape around there, and that will keep the rain off our little pooling area down there where it can freeze up and help make this thing less waterproof. I hope you guys enjoyed that, and catch you next time.